that wasn't enough, let's now do it with calculations, because this is when it gets really fun. If we're calculating an answer, we can't get more precision than we did when we started. In other words, if I multiply something like 2.3 times 1.4, and, oh, I lost my calculator. Okay, so 2.3 times 1.4 gives me 3.22. So here's what I did, is I started with two significant digits, but my answer has 3. Well, you can't just get more precise just because you multiply. It doesn't work that way. So what you have to do then is round this one, because it cannot be this precise. When we're multiplying, when we're dividing, what matters is how many significant digits we have. So this one starts with 2, this one starts with 2. The max my answer can have is 2. So I have to round this one off. So I'm going to round off to the nearest tenth, because here's 1, here's 2. So I would get 3.2 for my final answer. Alright, let's say we wanted to do some more. So let's say that I'm going to take, let's go 1.2 times 0.433. Now the first thing that we need to do is do the math. So just calculate it out. 1.2 times 0.433, and I get 0.5196. Now once again, this one has 2 significant digits, this one has 3, so my answer right now has 4. Well, I don't get more precise by multiplying, so this is not right. What I'm going to do is I'm going to look at these right here. I've got 2 for one of them, I've got 3 for one of them. The smallest number wins. So my answer can only get 2 significant digits in it when it is done. So this first 0 is not significant. So I'm going to go 2 places after that. So I'm going to go that far. I need to round off to the nearest hundredth. Well, if I look at the next number, that's a 9. That means I'm going to round up. So my answer would be 0.52 when I round up. Same thing true for division. If I go 2.8 divided by 6.4, 2.8 divided by 6.4, and I get 0.4375. Once again, 2. Answer's got 4. Can't do that. My answer can only have the least of my factors. So it can have 2. So therefore, I've got to round off so that there's only 2. Not significant here. So here and here, I'm going to round it off, and I would get 0.044, not 0.044, 0.44 for an answer. All right, let's do some adding, subtracting, because adding, subtracting is a little bit different when you add and subtract. Let's say that I want to add 2.1 and 1.43. What I would suggest you do, what I always find the easiest, is to just first add it all up. So let's get it, 3.53. Then what I need to do is figure out how far to the left am I going to go. So look at that. That goes to the nearest tenth. This one goes to the nearest hundredth. But think about it. If I have an error that's in the tenth, that really overpowers the error in the hundredth. So my answer has to go to that place right there. So I'm going to round off, and I'm going to get 3.5 for an answer. All right, try another one. Let's say I have 2.00, that sounds good, minus 1.4 What am I going to get? Well, if I just subtract down, I'm going to get 0.60. Now, if this were multiplying, dividing, we'd worry about how many we have. This is adding, subtracting. We worry about where those are located. So this one, well, I go all the way to there. That's the significant digit farthest to the right, I guess. In this one, the significant digit farthest to the right is at 0. So this is right there. So even though now, when I do this, it looks like I lose a significant digit, this is the right answer that I should get. So adding, subtracting, we worry about how many are in the factors that are involved in it. Multiplying, dividing, we worry about the location of those factors and what we have. And then we just kind of carry it down. All right. Hopefully, after reading over that and going through this, you have an idea of significant digits. In Dropbox, you should also see a video called the Big Sig Fig something or other. You should watch that too. That just gives you another way of looking at significant digits. It explains it in a different way, but also a good way. So just another option of what you can do here. All right.